Hey, this video is going to be quite long, so be sure to click below the video on the Show More button, and there'll be a table of contents with links to topics and minute marks. If you click on those minute marks, you can jump to that section of a video. Welcome to Excel 2010 Business Math video number 31. Hey, if you want to download this workbook, Excel 2010 Business Math Chapter 3, Section 3.5, or the PDFs or the PowerPoints, click on the link below the video. Hey, we're going to start on the sheet Learn, Increase, Decrease. I'm going to start sections 3.5. But before we jump into 3.5, let's look back at what we learned so far in this Chapter 3. We want to remember the basic percent formula, part equals base times rate. And we're going to remember a problem we did back in section 3.2. If last year's sales were 500,000 and this year's sales were 110% of last year's sales, how much are this year's sales? Now, we already did this one problem using this formula right here. But now we're going to look at this from the point of view of an increase or decrease problem. Because the rate is greater than 100%, we know it's going to be an increase problem. Now let's break this down. If I were to directly translate this into words, it would be equal to something like this, all right? So this year's sales were 110% of last year's sales. So I'm going to put in parentheses this. All right, so this year's sales, I'm just taking it straight from the words, were, that's like an equal sign, right? We usually think of is or are, but were can also be an equal sign. So this year's sales are equal to, well, there's the rate, and I'm just going to put, it's actually long. It's this year's sales as percent of last year's sales. I didn't put the apostrophe in the right place there in either case. This year's sales as a percent, that's actually the name of that rate. This year's sales as a percentage of last year's sales. That's the actual rate. And then there's the word of, so we put times of last year's sales. So last year's sales. So let's look at this. Which is the base, which is the rate, and which is the part? Well, there is the rate. So I'm going to start off with rate times some amount. That's going to be the base because we started last year. So that's going to be the base. If only I could type. And then equals this year's sales. Oh, that's the part. And as we studied back in section 3.2, the part can be something less than the original base, equal to the base, or greater than the base. All right? All right, now we're going to list our variables. We're not going to do it set this up as a word problem. We will later. I just want to examine how this problem is going to look in this section here. All right, because we already did this one before. Let's put 500,000 here. Control-Enter. Looks like it's already formatted. That's good. This year's sales as a percent of last year's sales, I'm going to put 110. Because that percentage symbol pops up, you know it's already been formatted. And then this year's sales, well, we're going to calculate that. What we want to see here is the new terms. Now, this was base, because that's where we started. This was rate. And when we multiplied that, that'll always give us part. But now, in the textbook, they use original amount and new value. I am not going to use those words. I'm going to use, if this is the base, that means the point at which we start. So I'm going to say begin amount. Now, actually, later I'm going to shorten that to begin, and we'll formally introduce that later. But that's the begin amount. This is the rate, and this will be the end amount. What's nice about begin and end and things like that is these were last year's, right? We went through time and got to, these were last year's. We went through time and got to this year. So we had a begin amount and an end amount. We'll see stock examples where we have the begin amount will be the what the stock was worth at the beginning of the year, and then the end, that'll be our end amount. All right, and we're going to refer to this as end. So we just use our formula we already know. Base times rate, so boop, times boop. And there it is, 550,000. All right. Now, this, in this chapter, this is called a, what? An increase problem. Hopefully I didn't spell anything too badly there. All right, now let's look at another example. If last year's sales were 500,000 and this year's sales were 90% of last year's sales, how much are this year's sales? All right, let's just come down here. Last year's sales, okay, 500,000. Enter. The rate is going to be 9. Now notice as soon as I type, it's already been pre-formatted, so I know I can type 90%. This year's sales, well, I'm going to use my new terms here. This is the B, and I'm going to use BEG for begin. This is the rate, and I'm trying to calculate the end amount. So now I'm going to multiply these. 450. So then this is what? A decrease problem. We went down. Now, what's nice about the variables we'll use here and some of the formulas we'll use is the formulas for increase and decrease problems that we'll use will work the same whether we're doing a increase or a decrease problem. All right. So begin, rate, end. Now, we're not going to use these terms anymore in section 3.5 because they, you know, using BEG for begin and END for end will help us always remember where we started and where we're trying to end up. All right? So I want to come down here. In both of these cases, we just used up here, right? We used part equals base times rate. But now that we have increase, decrease, I want to use a different terms here. So our end, which is really part, and notice I have the same with different words, right? So this is really what we're doing. End equals the begin times the rate. So the rate is still the same word. It's just we're going to use end and begin. And in this video, as we go down, I've conditionally formatted these. So as we introduce a new formula that we'll have to remember, it's going to turn red there. And then later, I have a summary of formulas on the next sheet over here. All right, well, what about rate? Well, OK, so the rate formula is going to equal, well, instead of part and base, we know part is end, and base is begin. So I'm going to say end divided by begin. And finally, if we're solving for base, oh, wait a second. The base, that's where we started, right? So that's the begin equals, oh, and the part, well, that's going to be where we end up each time, divided by rate. So these three formulas are how we will refer to our older formulas in this chapter. And again, the reason why is because then it's easier to figure out which is the end and which is the beginning. We're always going to be moving, right? With increase, decrease problems, we're always moving from some amount to some other changed amount, whether up or down. All right, now let's come down here and let's look at our first example. We can even keep that. Not only that, but there's a cool trick. When we get our increase and decrease, we're going to do a few calculations first. But then we're going to come draw a picture. And we're actually going to draw this picture in Excel. And the colors will help a lot. All right, so this is a rate of change increase problem. Last year's sales were 500,000. This year's sales were 550,000. Now notice, we're given two different numbers. Up here, we were given the begin amount and the rate. But that's not always going to be the case. Sometimes we're actually going to have to calculate rate, right? And so in this case, we're given two different numbers. All right, so the rate. OK, the rate we can figure out equals, and you have your little list of formulas right here when you're learning it. But eventually, you probably will remember some of them, right? N divided by begin. Oh, N divided by begin. Now, we did this also back in forget what section it was. Oh, our last section, 3.4. This end amount, or as we referred to it before, part, can be less than 500,000, equal to 500,000, or greater than. Anytime the end amount is greater than, the resulting rate will be greater than 1. If it was exactly equal, then the rate would be 1. If the end amount in a decrease problem is less, then the rate will be less than 1. All right, so I'm going to hit Enter. 1.1. Now that's 1.1. Why is it greater than 1? Because 550,000 is greater than 500,000. If this was exactly equal to 500,000, just to illustrate a point, what would this have to equal? 1. What if it was 450,000? That would have to be less than. Now, that was just to illustrate our problem here is 550,000. All right? We get 1.1. Now, I want to label these. This is what? Last year's sales are the starting point or the begin. This year's sales, we went from here to there, so that's the ending point. And this will be called rate. All right, now let's show this rate as a percentage. I'm going to say equals this. Control Enter. Now I'm going to apply some number formatting. Notice I have my ribbons hidden, and I did that by right-click, and I can either check minimize, right? Check it and it hides it. Uncheck it and it unhides it. The keyboard is Control F1. Control F1. You don't need to know that. Control F1. All right, I'm going to apply some percentage with 2 decimals. Right now, and when you're doing your problems, either, as we've studied so far in Excel, either one of these will give us the correct calculation for formulas. But sometimes people will prefer this. Sometimes people prefer this. And if your boss or the textbook says percentage, then show it as a percentage. All right. So this is the same rate. It's just shown as a percent. All right. Now, what about the amount of change? So we went from 50,000 to 550,000. I'm sorry, 500,000 to 550,000. So of course we can calculate the amount of change. We say end minus begin. And I'm going to, from now on, this is amount of change. And this will be important, especially when we draw our little pictures. Just a moment here. So I'm going to refer this as amount of change, AOC. Now, notice that because the number is positive, it means we went up, right? Now, I mean, to most of us that seems obvious, but later when we get negatives, that'll be helpful because it'll tell us we went down. Now, here, this is a new formula here. We haven't done this one before, so I'm going to type it here. The amount of change equals end minus begin. You always want to do an end minus begin because later we'll see a decrease problem, and then this will come up negative, and that'll tell us that is, or no, not it'll say, oh, we went down. Sometimes you want to go down, right? Like if it's costs from one expense to the next year, from one to the next year, if it went down, that's good for a business in general. All right, that's a new formula, so I put it in right here. Now, rate of change. Well, what's rate of change? Now, we do want to make sure, and I have these little, when there's a little red thing in the corner, it's a comment. If you just hover your cursor, it'll pop up. We absolutely have to distinguish between rate and rate of change. Rate of change will be the little bit above or below 1. So we can see that since we went up a little bit, this 1 has a little bit extra, right? That's the rate of change. So what's the formula for rate of change? Well, we already calculated amount of change. You just compare it to the begin amount, right? So you say equals the amount of the change, and you compare it using division to the begin amount. And that says, oh, 0.1. So if we format this as a percent, that says our sales went up by how much as a percentage or a rate? 10% or 0.1. Now notice there's a cool little relationship here. Anytime you have an increase or a decrease, right? It'll just, for increase, it'll always say 1. If you were to do an equation, it would be 1 plus the rate of change. All right? So this is rate of change, and we're going to refer to this as ROC for rate of change. And what is the formula for rate of change? Well, we have to make sure that we look. What do we do here? F2. Oh, amount of change, and we compared it to begin. So I'm going to make sure that when I write my formula, then in the numerator, I write n minus begin. So, and we have to do the subtraction before doing division. So what do? Order of operations. I put end minus begin in parentheses. Oh, divided by begin. Right? And so that is a new formula for us. That'll be rate of change. Now, that problem right there, the best way to do this, and especially if you're having a hard time, is to draw pictures. Now, notice there's a big part here, and a little part, and a bigger, 2 parts that make up that. And we're going to have another big part here and 2 little parts. Let's just start with this one. Oh, we have the end amount. So I'm going to write here END, enter. And you can either type 500,000 or you can type in equals, or 550,000 and click an equal sign and do that. Typing it out is easy. This whole block here is going to represent that 550,000. Now, what 2 parts added together would give us 550,000? Well, the begin and the amount of the change. So I'm going to write here amount of change, enter. And now you can type it in, or I'm just going to go give me that $50,000 there. Well, what do we have to add to that here to get 550? Oh, the begin amount. So BEG. And then this 500,000 here. Now, what's nice about this is we actually could have drawn this first. In the next example, I'll actually show you how to do that. But if you don't know this, if you draw the picture like this and just leave it blank, it'll be a mental prompt to say, oh, yeah, I think I can figure out that right there. And then you figure it out. Now, what's this one? That's the big part. What's the other big part that actually visually has to be parallel to this size over here? It's the rate. So the rate, enter. And I'm going to say equals this. You could type it in if you want. Now, if this is the whole rate, there's got to be 2 parts, right? Well, I bet you we could figure out this part. This is going to be the rate of change, right? So I'm going to type ROC, rate of change. And that's going to be equal to 10%. Again, you can type it in or do a little formula there. Well, what in the world is this? Well, the begin rate, and they don't call it this in the book, but there is a begin rate. What is it? We actually saw an example. If I change this to 500,000, oh yeah, the begin rate would be 100% or 1. So I'm going to undo that and keep that 550,000. This is going to be the 100%. So drawing this little picture will be helpful because, again, sometimes that's the piece you're solving for, and this will be a visual prompt to say, OK, I got to get that. Other times, you'll be given these 2 things, and you'll have to calculate that. Oh, like we did here, right? Other times, you'll be given these 2, and you'll have to calculate this. Now, there's a good insight. The rate is always going to be equal to 100% plus whatever the rate of change is. So I'm going to type, and then I'm going to actually write a longer description here and then put the formula down here. I'm going to say this is the rate. Remember, this is the big part, and it always has 2 parts together. So I'm going to say rate, and I'm going to say always equal to what? 100%. Or you could put 1 100% plus the rate of change. Always. And notice I used the word always there, so that means it better work the same for decrease problems. And the way we do it, it will. So I'm going to shorten this. I'm going to say rate is always going to equal to 1 plus rate of change. Oh, and that's another one of our formulas. It turned red there. Now, that formula is useful everywhere. This formula is useful in budgeting, in finance, in statistics, in all sorts of places, right? As soon as you know the rate of change, like the stock market went up by 2%, then 1 plus 2% will give you the rate. Well, oops. If we were able to figure out this formula here from this little two-part diagram, you think we could figure something out over here? Oh, yeah, sure. This one's probably even more obvious, right? Because we've all done addition and subtraction before, starting point and ending point. We may not have all had done rates and rates of change before. But begin plus amount of change will always equal end. And again, I put always because it'll work for increase or decrease formulas. All right, so really what we want here is, I'm just going to type it, begin, sorry, I'm going to say end equals begin plus amount of change. All right, and there's another formula. Now let's test this theory right here. Let's go ahead and we're going to try it. Rate. Well, what do we need? We need 1 plus rate of change. Now, in this problem, we had to calculate rate of change. A lot of the problems in the textbook and in the real world, you're not given the rate. You're just given the rate of change. A lot of times in finance, when estimating what things are probably going to be worth in the future, you always say, well, I think it's going to go up by 10%. In budgeting, you do the same thing. You say, I think revenues are going to be 3.5% increase next year, or the economy next year is going to shrink by 0.5% or something. So let's test it. I want to calculate, see the rate, see if I can calculate it using 1 plus rate of change. So equals 1 plus. Now you get the same number, the same answer if you put 100% here. The formula would actually have to go through an extra step in calculating, so why bother? It takes less time to type, and the formula will calculate faster. Not that we would ever see the difference, but all right, so that's it. 1 plus rate of change, and I better get, boom, 1 point. Now, it sucked the formatting because I clicked there, but 110%, that's it. If you wanted to do it the other way, equals 1 plus, and you click on the non-formatted there. That is going to, this little formula right here is going to come in quite handy. Right? And a lot of the problems in the textbook that seem like they're tricky, if you just remember, oh, I can get rate, given that they gave me the rate of change, that's kind of going to be the trick of solving the problem. Now, let's do a decrease problem. And two things here. We're going to see that we can use the same exact formulas, and we're going to use this picture here to help us. Now, let's just see if we can fill out the picture here. Now, the picture is going to look slightly different, because what's true? What's the bigger part here? Is it the begin or start or the end? It's the begin. So I'm going to put begin here. And then I'm just going to get this 500,000, right? OK. So the picture there, what other? It's made up of two parts. And what part do we? Oh, we have. And so we'll put begin here. How about that? We'll be polite to ourselves. We'll label it as we go through each one. And this one, if this is the begin, this one, oh, this is the end. Oh, bummer. Our sales went down. No problem. Still, the same formulas will work. So end. So this is going to be the end. And then I'm going to get that number. All right. Now, just from this picture right here, could we figure out the amount of change? Yes, we could. Now, I'm going to come right to here before we even figure out rate, because we can figure that out. I want to calculate amount of change. And we already, our formula for amount of change will always be end minus begin. That way, if we always do it in the right order, it'll tell us whether it's up or down. So equals end minus begin. Now, what's true if you take a smaller number and subtract a bigger number? You're going to have a negative. Now, what happened there? Those parentheses, there's no accounting requirement for this class, so that parenthesis comes from accounting, but no problem. It's sucking the format from there. I'm going to see if I can find anything here. OK, it looks like it probably has some format. But notice there's a little dash there. So you could do this one. Oh, that worked. If it didn't, where would you go? Formatting. The best place for you to have power over any number format is go to the Number Format Cells dialog box, or Control-1. It's the Format Cells dialog box and the Number tab. Under Currency, very polite. You have all sorts of choices for how you can display negative numbers. Click OK. All right, now we can come down here, and we can finish our little picture here. The amount of change will be equal to that. All right, so we started with these two. It may help to draw that picture, because then we calculate the amount of change. But what about this? The problem in this particular situation, they say last year sales were this, and this year sales were this. They don't give you any rate or anything. So I'm going to do some calculating first. Now, rate. Well, what is rate? Rate, our new formula is going to be end divided by begin. Now, if you want, as you're kind of learning how to do things in this section here, you might want to write the old terms off to the side just as a prompt to help you remember. So begin, that's where we start. That was always the base. The end, I still like end better than the word we used to use for increase, decrease. It was called part. And then this rate was called rate, right? So, and then if we did it with our old variables, it would be the part divided by the base. All right, let's go ahead and calculate it. So end, divided by begin. Now, what's going to happen? This number, the top, the numerator, that's smaller than the denominator. So it better be less than 1. And sure enough, it's 0.9. So our rate is always the number we can multiply by the begin amount to get the end amount. And you might even check over here, right? Check end. So it would be equals, oh yeah, the begin times the rate. And we better get 450, right? Oh, excellent. So there's our check. All right, now what about rate as a percent? And I'm just going to do it in a separate cell as we're learning, right? So I'm going to come up here. Now, these two numbers, depending on the textbook, your job, your preferences, because both numbers will always give us the correct answer. So here we use the 0.9. If we were to go equals this times that, because formulas never look at the number format on top, they look at the underlying number. Of course, it's going to give us the right answer also. All right, so we have a rate. Now, well, wait a second. That's less than 1, right? And we know we're going to need 100% here somewhere. In our increase problem, our job, and for either, whenever you're drawing a drawing, you put the bigger thing and then the two parts. The bigger thing and then the two parts. But down on a decrease, what's the biggest thing? Well, if we went down, our rate of change is going to be minus 10%, right? So the big thing is going to be the base rate. And I'm going to put 100%. Remember, where we started is always 100%. And now, we can put our rate. And I could list this here, 90%. Now, we could figure this out here doing some arithmetic. But let's go ahead and calculate it off to the side. And actually, in just a moment, I'll show you we will have a new formula that'll make it quicker than having to go through rate of change. Now, what is our formula for rate of change? Oh, yeah. It's amount of change compared to the begin amount. So the formula would be end minus begin divided by begin, right? So it would also be shortened to this, but sometimes we don't have a cell where we have this calculation, but it could simply be, hey, amount of change divided by begin. Whoops, I'm going to make that capital OC. But this is the full formula, right? So I'm going to say equals, I've already made that calculation, and I'm going to compare it to the begin amount. Now watch what happens. It's going to come out what? Negative. Any time you have a negative, one of the numbers is negative, the other one's positive, and you're doing division, the resultant number will be negative. Now here's the deal. That's handy. The rate of change, because we did it this way, will always tell us whether it's an increase or decrease. And a minus is always a decrease. Now let's show this as a percentage. Right now we can come over here and simply list our rate of change, and that is 10%. All right, so oops, I have this here. The same two formulas always hold, and we can check them here. I think I'm just going to copy these right here. I copied and paste. Notice when you copy something like that, I copied that little piece. All I had to do was click here, and it automatically pasted it from the same size. This, of course, is going to be true. Oh, that's why this formula is so handy. Let's check this formula. Right over here, we can try it. So we have our rate of change up here. So I'm going to say equals 1 plus the rate of change. All right, so that works out. It's exactly correct. So that formula is nice, or this one right here is nice because it'll work for increase or decrease. We could also check this one, begin plus amount of change. So we could say check, and that would give us end. And this also will work no matter whether it's an increase or decrease. So I'm actually going to go up here and say equals, there's our begin, plus our amount of change. Notice because it's negative, boom, we get the correct answer. Now, OK, so we've done an increase and a decrease problem. We've learned some new formulas. We learned how to draw this picture. Pretty handy. All right. Now I want to go back up here, and I want to introduce. We did rate of change here. We got 0.01. We saw that this formula worked for increase or decrease. Now there's two other forms of this formula here that we can use. And depending on your situation, it may be handier to not use this one, but to use a different form. So I want to actually go over to take this formula. Remember, rate of change equals, in parentheses, end minus begin divided by begin. And I want to go over to the PowerPoints and draw something. All right, so I want to write our formula. Rate of change equals end minus begin, all divided by begin. Now, before we transform this into something that's more useful, I want to go back to fractions and remind ourselves of how to add length fractions. So I'm going to say 3 over 2 minus 2 over 2. Now, how do we do this? Because they're length fractions, right? They hang out, they like each other, they go to parties, they like each other. Well, no, because the denominators are the same, we can simply write the denominator, take the numerator, the plus or minus operator, and the numerator of the second one, and rewrite it. Right? So then this becomes whatever, but we're not interested in that. I just want to notice something. Is that an equal sign right there? Yes, it is. So that means this is equal to that. So we started here and went to here, but it's perfectly all right to start here and go back this way. So it just takes, you have to notice, there's a plus or minus up here. Yeah. So you can break apart the 3 and the 2 into two different fractions and put them over 2. And you take the operator and you put them between. All right? So that's what I want to do up here. I want to say, oh, and you know, here we're doing these weird math operations with words. But just think of end as the number 3, begin as the number 2, right? So this right here is what this looks like right here. So I'll even write it again down here. So end minus begin divided by begin. So there's no problem. They're words that represent numbers, so we just do it what? Oh yeah, there's a begin, so I can write two different fractions, each with begin. Whoops. Pretend I didn't write that there. So that is a denominator, and that's a denominator. I'm going to take a minus. I'm going to put the end. All I did was take that. I'm going to take the begin and put it right here. All right, but now just ignore this. Well, how is that more useful? That couldn't possibly be more useful, especially if we're typing into Excel. That's the more useful one. But let's notice. Begin divided by begin. Well, what's 10 divided by 10? 1. Truck divided by truck, 1. So anything divided by itself is 1. So here is the more useful version. End divided by begin minus 1. And this formula is great because you'll find it in statistics, finance, budgeting, all sorts of things. So we're going to go over to Excel and see how we can use this formula. All right, so I have a new formula here. And the formula is going to go right here. So equals, end divided by begin minus 1. So that'll be one of our new, whoops. I don't know why I put an equal sign. Equal sign said it was a formula, so I'm just going to write it there as text. Okay, so this is rate of change, and this is rate of change. Let's try it. This is exciting. Equals end divided by begin minus 1. And so that worked. We could format it or not. Now, let's notice something else. What's the formula for rate? Rate equals end divided by begin. Okay, and we already, let's see, right there. There's our formula. But I just wrote it there. Well, if rate equals this part right here, and down in this formula, we have that exact thing. Is it all right to substitute the word rate in? Because sometimes we are given the rate, and the quickest way is to go rate minus 1. And that'll be always the case for increase or decrease problems, as long as you have your rate of change listed as a plus or a minus. So there it is. Rate, either one of these formulas will work. Let's try it. Equals rate minus 1. Now, this one you can kind of right? After you use decimals and percentages after a while, you can get used to it. You see 1.1, that's an increase of 10%. But here's formally what you're doing, right? So either one of these formulas will be helpful. And again, in the homework and in the real world, you're not always given all the parts, and you have to figure out. That's why it's helpful sometimes to have 3 formulas that all calculate the same thing. Now I have a little screen tip right here in Excel that reminds you of what we did over in PowerPoint. All right, let's go check this out. Let's see if this is actually true. I'm going to try this. OK, so one of the possibilities for rate of change is end divided by begin minus 1. So let's try that. Equals end divided by begin minus 1. Oh, I still got minus 0.1. And then the other one, you can notice that, oh yeah, that's just rate. I'll even, so right there, you see that right there? So I can just write it like this. Equals, oh, and we have our rate calculated already, minus 1. And there we go. So either way. Now, there's lots of formulas. I have a summary sheet over here of all the things we solve for and all the different formulas. So there's a nice summary here. Also on this sheet, as we encountered them, they appeared in red. Now there's one last couple things we want to do here, and I know this is an epic video, but all of the mechanics of how we learn increase and decrease in rate of change problems and all the formulas are in this video, and then we'll have a couple examples in the next couple of videos. Sometimes you are calculating the end amount, like in finance all the time. You have a stock value at the beginning of the year, and you want to estimate what you think it'll be worth at the end of the year. So calculating end is important. Sales, budgeting, all sorts of things, right? You know that you made $10,000 this year in revenue, and so you're estimating a 15% increase, so you have to calculate what you expect your revenues to be at the end of this year, which would be the beginning of next year. So let's look at the same example again. Begin, and we're given the rate of change. Well, if we're given the rate of change and we're not given the rate, can we calculate the amount of the change? Well, sure. We can say 500,000 times the rate of change, right? That would be amount of change. So amount of change equals begin times rate of change, not the rate. If we did begin times rate, that would give us the end. But no problem. If we have the rate of change, we just multiply these two together, and boom, we have our amount of change. All right, from that, can we calculate this year's sales or the end amount? Sure, we can add. Okay, so this one would be end equals begin plus amount of change. So it's perfectly legitimate to do that way. But let's take a look and see if we can figure out another way also. Well, we already saw a different formula for rate, right? Rate is 1 plus the rate of change. So if the problem gives us 0.1, no problem. We can calculate our rate. Right? This is always, the rate is always going to give us the end amount when we multiply it by the begin amount. Rate of change will tell us how much up or down we increased or decreased. Rate of change and rate. All right, so once we have that, we know the rate and last year's sales. Well, now we already know the formula for end amount. It's always begin times rate. So begin times rate. So that's still another way. Notice in both of these situations, we're only given two inputs, but we're able to calculate this year's sales. And finally, if we notice begin times rate, that's a formula for end. We could go like this. End equals begin times. Instead of putting rate, can we just 1 plus rate of change. So we could go like this. And again, why are there so many formulas making your head spin? Because different times you want different formulas. And this formula is used in finance all the time. Later, when we get to the chapters in finance, we'll be using this often. All right, and so that's our last formula. So let's try it here. Notice this one we had 2 steps. And this one we had 2 steps, but here it's all in 1 step. And in finance, this is what you'll see. You just say, hey, there's the start amount times, in parentheses, 1 plus whatever the rate of change is, up or down. So when you see 500,000, I had some formatting there. Just to show you this method 3, this is the most condensed kind of one there is, method 3. But let's. Our begin amount is 500,000, but our rate of change, I'm going to type minus 0.1. There we go. All right, so equals, starting amount times, in parentheses, 1 plus. And what's 1 plus a negative? It's like a subtraction. There's the correct answer. So again, this formula, that's a preview of what we'll see in later chapters about finance. All right, that is a lot. We saw a lot of formula 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so if you come over to Summary of Formulas, there's all of the formulas. I've listed it here. Here's what we did in earlier sections. Here's all the things we're solving for, and here's are the different possible formulas you can use. All right, next video we'll do a couple of actual problems. See you next video.